Welcome back to the AI Daily Brief. Today we are having a really fascinating conversation that has implications for everything in AI, from safety to the business of it, to technology frontiers, to applicability to regular life, and all sorts of interesting things bottled up in this one conversation around whether the pace of development of AI is actually slowing. Now, this is not a new conversation. It's something that has been debated for a very long time. And by the way, there are wildly divergent opinions here. There are some folks who think that you can just add more compute and more data and get more performant models. There are others who think that there is no path to AGI with the current architectures we're using. This debate is why people like Yann LeCun can, with a straight face, say that they believe that AI is dumber than a cat. And of course, the implications of that view are significant. In the particular case of LeCun's point, it means that to him, all of these existential X-risk type concerns are way, way overblown. Now, what no one is arguing is that AI isn't extremely valuable, even in the state right now. One of the things that I've often said is that even if AI stopped developing in this moment, it would still take years for the world to adopt and adapt to the new processes that have been made available by just the technology that we have in this moment. However, it still would be fairly significant if, in fact, the rate of AI improvement was decreasing significantly. All right, so let's start by discussing where this conversation, or at least this iteration of the conversation, actually came from. The TLDR is that the information reported that OpenAI are apparently looking to develop new strategies to deal with the slowdown in AI improvement. Back in May, OpenAI CEO Sam Altman had told staff that he expected their latest frontier model, which they're calling Orion internally, not GPT-5, he believed would be significantly better than last year's flagship model. At the time, OpenAI had only completed 20% of the training process for Orion, and it was apparently already on par with GPT-4 level. However, now that there have been a few more months of work, things are starting to look a little bit different. According to the information sources, employees who have tested the Orion model found that although the performance does exceed the current models, the jump isn't nearly as profound as the improvement from, for example, GPT-3 to GPT-4. There are even some use cases where the model might not be consistently better than the previous state-of-the-art. According to one employee, while Orion does better at language tasks, it doesn't necessarily outperform when it comes to coding, which, given how prominent coding is as a use case, could be a significant problem. Now, what this is leading to is a different approach to thinking about scaling. The information writes, in response to the recent challenge to training-based scaling laws posed by slowing GPT improvements, the industry appears to be shifting its efforts to improving models after their initial training, potentially yielding a different type of scaling law. Another approach, OpenAI has apparently created a foundations team to figure out how the company can improve their models, given what is increasingly a scarce supply of novel training data. Those strategies reportedly include training Orion on synthetic data produced by other AI models, as well as doing more to improve the model's reasoning process during the post-training process. One of the big challenges is that at this point, the current frontier models have effectively been trained on pretty much all of the internet's data. Still, by far the more interesting shift here is about thinking about scaling simply as a matter of pre-training to instead thinking about the post-training implications. And this gets back to something that we've talked about a lot here, the idea that O1, which is of course OpenAI's more advanced reasoning model, is a fork on the evolutionary tree of LLMs. Sam Altman, when he announced it, was clear that this reasoning model represented a separate path from GPT-4. At the time, it was assumed that OpenAI would parallel process these paths, but increasingly it seems like they're leaning into the reasoning path. And by the way, it's not just OpenAI who's dealing with this problem. A few weeks ago, Alex Heath of The Verge reported, "I've heard that the latest Gemini model isn't showing the performance gains that Google had hoped for, though I would still expect some interesting new capabilities. The chatter I'm hearing in AI circles is that this trend is happening across companies developing leading large models." Former OpenAI chief scientist Ilya Sutskever spoke to this issue, stating, "The 2010s were the age of scaling, now we're back in the age of wonder and discovery once again. Everyone is looking for the next thing. Scaling the right thing matters now more than ever." And this once again gets us to what Turing Award winner Yann LeCun was pointing out in last month's Wall Street Journal piece. The WSJ wrote, "LeCun thinks that the problem with today's AI systems is how they are designed, not their scale. No matter how many GPUs tech giants cram into data centers around the world, today's AIs aren't going to get us to artificial general intelligence. There are also questions around whether synthetic data will actually create their own set of new problems, although that's far from clear as well. But overall, it still appears that OpenAI is planning to double down on their reasoning pathway. Last month, at an appearance at TED AI in San Francisco, OpenAI researcher Noam Brown said, It turned out that having a bot think for just 20 seconds in a hand of poker got the same boosting performance as scaling up the model by 100,000x and training it for 100,000 times longer. And while this does open up a new pathway for improvement, it also implies having a lot more computing power to serve answers. Sonia Huang, a partner at Sequoia Capital, said, "This shift will move us from a world of massive pre-training clusters towards inference clouds, which are distributed cloud-based servers for inference." NVIDIA CEO Jensen Huang also referred to this pathway, stating last month, "We've now discovered a second scaling law, and this is the scaling law at a time of inference." So where has the discussion been? First of all, there has been some confirmation from others that this is bubbling behind the scenes. Jan Peleg wrote, "Heard a leak from one of the frontier labs, not OpenAI. They reached an unexpected huge wall of diminishing returns, trying to brute force better results by training longer and using more and more data than what is published publicly." For others who have been saying this stuff for a while, they use this as a moment to reinforce their point. Professor Pedro Domingos wrote, "Scaling laws are S-curves, not exponentials." INSEAD Professor Jason Davis explained that a little further. He said this may be the most important strategic question about AI. Is the rate of improvement of LLM performance starting to decline? Are we seeing maturation in the S-curve? The report from the information gives us some data, but I think we really don't know, and is at odds with many insiders working on foundation models, especially since the effective performance of LLM systems will depend on complementary innovations that extend its usefulness. And perhaps many years of individuals and organizations finding the right use cases and configuring their workflows to leverage them. Others, including the information founder Jessica Lessin, wondered what the implications are for the data center business. She wrote, "If this continues, the slowing rate of gains in training LLMs has huge implications. One thought I had this morning, will being at the bleeding edge in chips matter as much over time? Will China therefore catch up to the US more quickly?" Others pointed out that of course there was always going to need to be something new. Sai on Twitter writes, "Pre-transformation architecture, AI had hit a brick wall. More insets and architectural tweaks will be needed to break successive barriers for improvement. It would be unwise to imagine that current LLM is the final solution." Perhaps the most salient message, though, is just that we need to think about scaling and training in a slightly different way. Estrella Intel on Twitter/X says, "AI hitting a roadblock? Give me a break. As if the diffusion transformer breakthrough hadn't happened. As if O1 reasoning isn't groundbreaking on its own. The only thing reaching a plateau is pre-training, and that's a milestone, not a ceiling. Pre-training was never meant to be the holy grail of neural network optimization. We'll inevitably move towards models that can actively learn for a reason." Hater at Slow Developer writes, "Even if current LLMs can't scale to AGI through compute increases alone, it's not a problem. OpenAI O1 shows further innovation are possible, and we haven't reached inference compute yet. Things are progressing even if LLMs don't magically scale to AGI with more compute." Professor Shelley Palmer writes, "There's been a lot of chatter about the end of LLMs or LLMs starting to fail. Those are only headlines, clickbait really. If you dig a bit deeper, you'll read that there are several schools of thought regarding how to efficiently scale the foundation models. If the goal is AGI, then just adding compute power to pre-training may not be the best path to follow. Instead, researchers are exploring an alternative called inference scaling to achieve smarter AI. Inference, the process when an AI model generates outputs and answers, can be optimized by having models quote-unquote think through multiple possibilities before settling on a response. This approach enables complex reasoning during real-time use without increasing model size. OpenAI's recently launched O1 model is a good example. By enhancing inference, O1 can tackle tasks that demand layered decision-making, such as coding or problem-solving, in ways similar to human thought. Test-time compute techniques make this possible, allowing models to dedicate more processing to challenging queries as needed. A move towards inference-focused distributed cloud-based servers instead of large centralized training clusters might create a more competitive chip landscape. While NVIDIA is the go-to chipmaker for pre-training hardware, there are a bunch of chipmakers, AMD, Intel, etc., that make hardware suitable for this new method of inference scaling. The key takeaway is simple. LLMs are not failing, they are evolving. Sensationalist headlines aside, this is how product development works. Every's Dan Schipper also pointed out that the framing of all of this was very problematic, and that it didn't really reflect the conversations that he's having with people inside the labs. He writes, "The message that this headline conveys is at odds with what people inside the big labs are actually feeling and saying. It's technically correct, but the takeaway for the casual reader, that AI progress is slow, is exactly the opposite of what I'm hearing." And indeed, ultimately, there was so much chatter to that effect that the information actually ended up clarifying a little bit. Stephanie Palazzolo writes, "Seeing lots of discussion after our Scaling Laws article this weekend. To be clear, we're not saying the world is ending, just that researchers are having to find new ways to improve LLMs, i.e. test time compute." That led to another article, "Goodbye GPT, Hello Reasoning O." And this basically gets to the point that this isn't about a halt, it's about an alternative direction and a new path that shows more promise than the previous. Still, it's a super interesting conversation, one that we will continue to follow closely. For now, though, that is the story. Appreciate you listening as always, and until next time, peace